Welcome to our second lesson on revision of our stoichiometric calculations. We'll be discussing the limiting reagent calculation today. Now to start from, we're going to be given this equation that says our ammonium nitrate plus sodium phosphate is going to end up giving us ammonium phosphate plus sodium nitrate. Now 30 grams of our ammonium nitrate and 50 grams of the sodium phosphate are given. So we've been given the two masses of our reacting molecules. Now the first question from here on asks us to determine the limiting reagent. Now in order to determine our limiting reagent, we would need to go and take a look at what is our mole calculation value at the end. Once we get the smallest mole value, then we know that is our limiting reagent. But before we are making sure that we do have the smallest mole value, we'll need to look at our mole ratios in the front of our molecules to make sure that they're on the same level to be compared with. So let's start off by calculating our number of moles for each one of our reacting molecules. So now do take in consideration that we end up here with 3 in front of our ammonium nitrate and just a 1 in front of our sodium phosphate. So once we've calculated our mole values, we'll need to make sure that we will either take the 3 back to a 1 by dividing with 3, or we can end up taking the 1 to a 3 ratio by multiplying by 3, but we're going to rather stick to taking all of these ones to a mole ratio value of 1. So as said, in this case, we would need to take our mole value at the end and divide it by 3. Now you can only multiply or divide, you can't add or minus. So now after calculating our mole values, we realize that our ammonium nitrate, calculating moles will be mass divided by the molar mass. We've got the mass of 30, molar mass values we're going to get from our periodic table, and we must make sure that we exclude the 3 from our molar mass calculations. And we're going to end up with a mole value of 0.375 moles. If you go over to our sodium phosphate, we've got 50 grams, 23 times 3 in this case because there's 3 sodiums plus the phosphate plus 4 oxygens, and that gives us a mole value of 0.3048 in a few decimal places, which we do not round off yet. Now we would realize by just looking at these two, it seems like the sodium phosphate has the smallest mole value, but remember they're not on the same mole ratio. So therefore, we said previously we're going to take our 3 over here and we'll divide it by 3. So that means we're going to take our 0.375 and divide it by 3 to get a new value to compare them as a 1-to-1 ratio. So from this, we'll realize we'll end up with a value of 0.125 mole compared to, seeing that sodium phosphate is still on the 1 ratio, 0.3048. So now my ammonium nitrate is the one with the smallest mole value and is thus the limiting reagent, whereas my sodium phosphate will be the value in excess now. Now our next question asks, what is the maximum amount of each product that can be produced? Now we would need to go and look at the amount of moles that we'll need to be using in order to calculate this. Now remember, we figured that ammonium nitrate was our limiting reagent, and the amount of moles calculated for a mole value of 3 or a mole ratio of 3 was in this case 0.375 moles. Now we will need to use this limiting reagent one when we go and calculate any one of the masses of our products. So let's start off by looking at our first product, which is our ammonium phosphate. If we want to go and calculate the mass, we'll need to use the moles together with the molar mass. And in this case, our moles, seeing that we're going to go here from a 3 ratio to a 1 ratio, we would need to divide our mole value by 3 so that we can then multiply it by 1 to have it on the same mole ratio value. Now it's also important to note that when we look at our amount of nitrogen present when we calculated the molar mass, there's a bracket with a 3 following after that. That means everything within the bracket that goes for our hydrogen and our nitrogen will be multiplied by 3. But the hydrogen also must be multiplied by 4, so that will end up being multiplied by 12 in total. And this will give us an end 18.63 when rounded off to 2 decimal places grams. Now let's go and look at our sodium nitrate. For our sodium nitrate, when we look at our mole values, we would note that they are 3:3 ratio. So therefore, whatever our mole values was for the ammonium nitrate would be exactly the same for the sodium nitrate because their mole ratios are the same. Now once again, we do not take the mole ratio in the front into consideration when we do our molar mass calculation. And from this we're going to get a final value, 31,88 grams of our sodium nitrate in this case. Now our last question asks us, what is the mass of excess reagent that remains after the completion of the reaction? Now remember again, the one in excess was our sodium phosphate. But we want to know now, after it has reacted with all of the ammonium nitrate, seeing that it was the limiting reagent, what amount in mass will now be left of this sodium phosphate? So what we would need to go and do is we would need to go and subtract the amount of moles used from our sodium phosphate, and from that go back and calculate the remaining mass. So we will take our 0,304 with all its decimal places, subtract from that our limiting reagent, but now remember it must be on the same molar ratio value, so we'll need to divide that 0,375 by 3 again, and then we will end up with 0,1798 moles. Once again, we're not going to round it off. It's not my final answer. From this, we're going to go and calculate the mass, which is then moles times the molar mass of the compound. So we're going to be using this new calculated mole value, multiply the molar mass, and round it off to 2 decimal places, ends up giving us 29,5 grams. That's now if you use all your unrounded off values during your calculation. So that is then the remaining amount of mass of your reagent that was in excess. Now the question which I would like you to go and attempt is to consider the following reaction given. Nitric acid plus sodium ends up giving you sodium nitrate plus hydrogen gas. If 1 mole of your nitric acid is used with 3 moles of sodium, determine the amount of mass in excess. So before you will be able to determine that, you'll need to make sure that your reaction equation given is balanced, as well as determining first off the limiting reagent, making sure that they're on the same mole ratio, and then from there on you can determine the excess. So first pause your play and attempt this before you're going to be looking at the answer.